In this video, we're going to take a look at how to write a unit test for MVVM LiveData with an observable. And we're actually going to test the data that comes back from LiveData in a unit test, which I'll tell you was a little bit tricky, which is why I want to put together this video. If we look at our class diagram, we want to focus on unit testing this view model here. And it's going to be a true unit test. So we're not going to worry about testing the plant service. As a matter of fact, we're going to mock the test service as part of our unit test. We're not going to worry about parsing JSON or anything like that. We're simply testing this view model and LiveData. A quick review of an animation we've seen before of what view model and LiveData is and how it's observed. Typically, we'll have our user interface over here, which can observe LiveData, or in other words, it can observe data that changes and it can react to that data. In a unit test, we'll typically wire something up to observe forever. The only difference is that observe pays attention to the Android activity lifecycle, when an activity is visible to a user, when it's obscured, and when it's been destroyed. Where observe forever is always observing. So we'll have our stream of data that comes out, and the stream of data that we're dealing with here is plant data that we're going to get from a JSON stream. Now, we're going to mock that, remember, because we're only testing the view model. We're not actually testing the integration all the way back to the JSON data source. And then our test is going to use this observe forever. In other words, when the data reaches our observe forever block, we're going to be able to do some testing based on this. What makes this a little bit tricky is that the view model, when it calls the plant service is going to be running in a separate process so that it can go out and fetch that data. So we have to look at a way that we can ask for some data to come back and then synchronize what would be separate processes so that we can get the results of that request. And then we can run assertions on the results of that request. To do this successfully, we need several inputs. One of them is something called coevery. Another is something called a CountdownLatch. And we also need to know about an observable. So let's start writing our unit test, and then we can come back here and look at these one at a time as we need them. I will add this to our existing plant test class. So at test, then we'll use the descriptive notation where we use the tick mark to spell out an entire given when then test as a method name. So function, given a view model with LiveData when populated with plants, then results show eastern redbud. And again, this is building on top of a given when then example that we had elaborated in our design document. Given a feed of plant data is available, when I search for redbud, then I should receive at least one result with the following attributes. Genus Cercis, species Canadensis, common eastern redbud. We could also use the second given one then if we want, which is when I search for Quercus, then I should have results with Quercus robur, English oak, or Quercus alba, white oak. Either one of those will be fine. Let's start by creating some given when then methods that this will call, or functions rather. So see, I've created the functions. Given view model is initialized with MockK data. When JSON data are read and parsed, then results should contain Cercis canadensis. Now we know I'm creating functions I've not yet created yet. So let's go ahead and create them with Alt-Enter, and I'm going to do them from the bottom up. The reason being, every time I have it create a method or function signature for me, it does it right underneath the function I'm currently in. So if I do them from the bottom up, they actually kind of end up coming in order. So we have given when then. Now we can focus on one thing at a time. Remember that our unit test is only testing the view model, not the classes that the view model invokes, because a unit test only tests one class at a time. So what we're going to do is we're going to mock the plant service, and we're going to mock the data the plant service will return to the view model. Let's start by coming up with the data that we want to use in this mock. So we'll say val plants equals ArrayList plant. And we already have the plant data class, so that part will compile. Now we simply need to add some plants to our plants collection. So I can say plants.add, and then we'll say plant, genus, Cercis, species, Canadensis, and then common eastern redbud. So you see what I'm doing is I'm constructing a new plant in line, and I'm adding it to this plants collection. That's one way we could do it. Another way that takes a few more lines would be val red oak equals plant, and then pass in Quercus rubra red oak. We could do it that way, and then say plants.add red oak. These two lines are very similar to this one line. It's just a matter of, do you want to do it in 2 lines or do you want to do it in 1? Let's go ahead and add our white oak just in case we want to create that test as well. So at the end, we have a plants collection, and that plant contains 3 unique plants: Cercis canadensis eastern redbud, Quercus rubra red oak, and Quercus alba white oak. And this will essentially be the mock data that we want to feed into our view model with LiveData. So we're going to need to declare a couple variables in our unit test. One is one that represents this view model, which, remember, we've not created yet, but that's the nature of test-driven design. The other is this plant service, which again we haven't created yet, but there again, that's the nature of test-driven design. So the view model is what we're testing, but the service is what we are mocking. In other words, we're just giving it basically a predictable thing that can be returned and used in our test. So we will create these a couple different ways. We'll scroll up towards the top, and for the view model, we'll say LiveData var MVM main view model. And again, remember, main view model is not going to resolve because that class does not exist yet. The LiveData simply means that we're declaring it here. We will initialize it later. Now, the service is a bit trickier because we're mocking it. So for that, we'll start off as we just started off with our main view model. We'll say LiveData var. Then we're going to say mock plant service of type plant service. I'm going to put an annotation over this MockK. Now what that means is take a look at the construction or the structure of this plant service class and just create basically a dummy implementation of it where we will define what all of the functions return as needed. This is using the MockK library, which we're going to need to import. I'll go back to build.gradle at the app level, and I'm going to add a test implementation for io.mockk, MockK 1.12.2. This is the latest at the time of the recording, but as always, just double check and see what the latest is and use that when you implement this. I do that and I do async. Now back to plant test. You notice once that sync is finished, I can Alt-Enter and that implements MockK. Now the next thing we need to do is we need to go ahead and mock out the method we want to mock out on plant service. So I go back to our given method, or given function rather. Let's mock that out here. We will use a MockK construction called coEvery. And this is essentially for use when we're trying to mock something out that occurs in a coroutine. What we do is we say, for this class and this function, whenever it is invoked, let's return this predictable result. So we have to define the predictable result, we have to define the class and the function, and then simply wrap it in this coEvery returns construction. We've already defined the predictable result right here, so let's add the coEvery. First of all, it wants us to import coEvery. Let's go ahead and Alt-Enter and do that. And now you see what we're doing. Let's take the plant service, and whenever fetch plants is called, let's return this plant's predictable result. Next, we need to attach this as a dependency to our main view model. So let's go ahead and initialize that main view model. And again, this main view model class is a class I've not yet written, but that's the nature of test first design. We know that the view model is going to need to have an association with a plant service. So we can say mvm.plantService equals mock plant service. And what we're doing now is we're saying, okay, well, view model, I would like you to take your plant service attribute, which is the use relationship that we see here between view model and iPlantService, which is the interface that plant service will implement. And instead of actually using the normal plant service you would use, let's use this mock plant service, where we've defined the mock above, and then we have defined the predictable results, and we've said that when fetch plants is invoked, we want to return those predictable results. Next, we have the when method. I have when JSON data are read and parsed, but you know what? I should really take that one level of abstraction up and just say when country service fetch countries invoked. Let's keep it at that country level, and what I will do is I will change it here. I will also change it where it's called up above, so there we go. Make it a little more clean. I'll confess I said country there, and I meant to say plant. I go back later and I change that from country to plant. Good news is this function is quite straightforward. All we need to do is call MVVM.fetchPlants. And guess what that's going to do? That's going to see our coevery here, and it's going to return our predictable list of plants. So the when is quite straightforward. The given is a little bit complicated, and the then is going to be complicated as well. Let's jump into the then. We will need to create something that implements the observer interface and overrides its only method or function signature, the function onChanged. This function will be invoked when our observeForever receives some live data that it's observing on. So what are some things that we're going to want to do? Well, we've received the data, so we're likely going to want to save it for testing. We'll also need to do countdown on a CountdownLatch, which I'll explain in just a moment. And then we'll say, okay, we've completed the test. We can stop observing on the live data so we can remove ourselves as an observer. Now, what's the CountdownLatch? Well, remember, observing live data is a little bit tricky because you're just waiting for something to observe. So it might not happen in a sequential order. CountdownLatch is really handy here. What we can do is we can initialize a CountdownLatch to a certain number. Then we can have our thread or our process that's waiting on results await on that CountdownLatch. And that thread would be our test thread. Then the thread or the process that is receiving these results can say, okay, I'm going to decrement the count because I have received these results. Once the result count reaches 0, then the await returns, and then our test can continue to process and evaluate the results it's observing on. We can also add a timeout if our countdown never reaches 0. So that's a little prerequisite. It's probably a little bit easier to see in code, and also something that I will show in a debugger in a few moments. Let's start by defining a variable that will hold our results. Let's say variable named allPlant of type list plants, so a collection of plants, and we add the question mark to say this can be nullable, so we'll want to assert not null as part of our test. We will initialize it to an array list of plants that's essentially empty. Now let's define that CountdownLatch. We'll start it at 1, which means we're expecting to have one process that's going to occur perhaps in a separate thread, a separate coroutine, or something like that. And when that process completes, it will count this down, or in other words, decrement it from 1 to 0. It's telling us here we need to import CountdownLatch. Let's go ahead and do that. Next, we need our observer. Remember, we need an implementation of something that overrides the onChange method of the interface called observer. So we'll say val observer equals object colon. Now what does that mean? That means we're creating a variable named observer, and to it we're assigning essentially a singleton or a static object. And that object is going to extend from observer. Now observer, you notice it has a generic identifier of type T here, which means we need to tell it what data it is expecting to receive in the onChanged function. And we expect it to receive a list of plant data because that is what our retrofit call is eventually going to return, a list of plant data. Now after this we'll do open curly and close curly. And notice that it doesn't know what observer is, so Alt-Enter. We will import it from Android Lifecycle. And now it says, wait a minute, this object, there's something wrong here. And the reason is that as soon as we implement this interface observer, we have to override all of the functions that are defined in that interface. Let's go ahead and say implement members, and you see it gives us onChanged. That's a lot of syntax, but let's just put it into perspective so we don't get lost in syntax. At the end of the day, this is the function that's going to get called when this little red bubble lands in our observeForever. And there are really only 3 things we need to do. Item number 1, save the data so we can write some asserts against it. Remember, we declared this allPlants variable up here, so we can assign it or reassign it down here. AllPlants equals, and then, well, what's getting passed in? Well, a list of plant data, and that's assigned to this variable called T. We could name that something more descriptive if you want, like received plants. Next, we need to count down our latch. And all that does is decrement it from 1 to 0, which means that this process is finished and we can continue with whatever's waiting on that latch. Finally, we need to remove ourselves as an observer because we've done our job. We've received our plants and we no longer need to be observing on this live data. So we'll say mvm.plants.remove observer this. Now wait a minute. We know that this main view model we've not yet defined yet, so we don't know what plants is. Well, plants is essentially the live data collection living on that view model, and that live data collection can be observed, so we say remove observer, we're no longer observing on that. So that's what's going to happen when we receive the live data. We need to take this observer and we need to attach it to our main view model. So we'll say mvm.plants.observe forever and pass in the observer that we just created. Now we're observing on that data. So we're going to observe on the data and we need to now wait for that live data to be populated. Now the live data is actually populated in the when up here where we call mvm.fetchPlants. And remember, that's going to go back to our mocked out function call here, which is going to return our predictable data. So that all happens up above. Nonetheless, what we need to do is we need to give it a moment for all of this magic to happen together. We are going to use our latch.await function. What this is going to do is it's going to sit here and wait until our countdown latch goes from 1 to 0. It starts at 1, the countdown takes it down to 0. This function will sit and wait until it reaches 0. Now what's important to realize is that these steps won't necessarily happen sequentially. Because you look at this and you say, wait a minute, it starts at 1, it gets decremented. Why are we waiting here? We know it's going to be decremented by the time it comes here. Well, not really. What's going to happen is these lines will run in one process. And then separately, the live data will get updated here. When the live data gets updated, this will run in a separate process. That will call the countdown. And then that will tell our main process here, okay, you're good, please continue. But what if this never runs? Well, we can add a timeout. So I can say timeout 10 and then time unit seconds. If the countdown latch never reaches 0, let's go ahead and time this out after 10 seconds. Finally, we can do some assertions. So let's assert not null, all plants. And then we can actually borrow something we created earlier. So I will borrow some syntax here. I could copy paste. I actually probably could just invoke that directly. I could maybe do a bit of refactoring later, but nonetheless, assert not null all plants, assert that all plants is not empty, and then we'll say, okay, does it contain Cercis canadensis? Let's assume no, but then let's iterate over the collection, see if we see a plant called Cercis canadensis. If we do, we'll flip the flag to true, and then we will assert true. So that finally wraps up this function, and there are just a couple other things I need to do to this class to finalize it. But I will say, right now you probably look at this and say, oh my gosh, what in the world is going on? And this is normally where I would like to demonstrate something in the debugger. But since this is test-driven design, these classes don't exist yet. But not to worry, I do have an example that we can take a look at where we can watch this happen in the debugger. I have that in a different project. We'll take a look at that in just a moment. But first, a few more things I need to tidy up here. Towards the top of my class, I'm going to make a new function, init mocks and main thread. And we'll say MockK annotations, init this. Alt-Enter to import. What that says is let's look for anything that is mocked like so, and let's go ahead and create an object out of that. That is pretty much boilerplate. The next thing I'm going to do is pretty much boilerplate as well, so if you don't understand the syntax, don't worry so much. Just know this is something that you need to use when you're testing something that is calling a coroutine. So I'll say private val main thread surrogate equals new single thread context main thread dispatchers set main thread surrogate. Again, a little bit of boilerplate. Don't worry too much about that. We're just saying run this all on a single thread. Now I want this to run before every unit test. So I'm going to say before. I could also say before class, which actually that would be fine. And before class means run this once before running all tests, where before means run this before every single test. Now I'm also going to have a teardown method, which is where we clean up any work we've done. And for that, we'll simply say dispatchers.reset main, and then main thread surrogate.close. Again, a little bit of boilerplate there, only needed if you're doing one of these coroutine tests, but nonetheless, that's what we need to finish things off. For this, we'll say after class. Now, I'll confess I'm having second thoughts on this. I'm going to change this from before class to simply before, and from after class to simply after. Before runs before every test, and after runs after every test. Here it doesn't matter so much because at this point we only have one test, although we might add more in the future. But the difference in programming is that before and after are a lot simpler on me as a programmer, because before class and after class has to be in a static function, which means we need to make a companion object, and that's going to take this main thread surrogate. We're going to have to do some goofiness with that, where before and after we can just treat it like a normal function. Now, if that rationale doesn't make sense about static object and companion object, and you haven't heard that before, don't worry. Just take my word for this. Before and after is going to be a little bit simpler here, and it's not going to have a huge impact since we're only running one test here anyway. And save. And with that, our coroutine test is done, but here again, I understand the syntax probably does not make a whole lot of sense because we can't visualize it. So let me show you this in the debugger in a different project that I have, where I did do test-driven design, and I finished the implementation. Given a view model with LiveData when populated with countries, then results should contain Belize. I'm going to debug this. First, we go into the given part, and notice, just like with creating some plants, here we are creating some countries, and we're adding them to a collection. Now we use the coevery to say anytime our mock country service gets a fetch countries call, let's return the mocked data. And then we're taking that mocked class and we're setting it on our main view model. And I'll say, okay, we're good with the when, we're just setting up our mocks, let's go ahead with that. Now we're at the then part where then results should contain Belize. So I'm going to step over this one line at a time, and I want you to watch the blue line and where it goes. So you see, we start by declaring essentially our result variable. Now we declare our CountdownLatch with a count of 1. Now we declare this observer variable, and we set it to this object that we're creating in line here. But watch as I step over, it simply goes to it jumps all the way down to the observe forever. So this code does not run yet. This code doesn't run until we receive an update to our live data. Now I step over. Now you see, okay, now we're back into that onChanged function, and now the all countries, we're receiving the all countries because we've observed it with our live data. We're counting down the latch, and then we're removing ourselves as an observer. And now I'm going to say, okay, thank you very much, continue. Now take a look at where we went next. That's kind of weird. We went from this launch.await now to the assert not null and to the assert true. So step over, it's not null, and step over, true, and run to cursor, and we should see that our test indeed has passed. Now what happened there? Well, remember, launch await means sit here and wait until our countdown goes from 1 to 0. As soon as this counted down to 0, the await was finished and it moved on to the next line. Now, an important thing to note is that it will move to that next line before this timeout occurs if that count goes to 0 first. So in other words, if the count goes to 0, it's not going to wait the full 30 seconds. It's going to say, okay, thank you, I have what I need, and it's going to go ahead and continue. So the timeout is just a matter of saying, how long is too long to wait? That is a look at our test-driven design unit test for testing coroutine data. I hope this video has been helpful, and I look forward to reading your comments. Thank you.